So somebody tipped me off that there's some rather large lumps of steel that are going to scrap, and both this piece and this piece I managed to get for not a lot of money. So I spotted these, thought that would make a very good power hammer anvil and power hammer top. Now I fired up the CAD machine and designed the power hammer. So the plan is, this is that large lump of steel you saw earlier, that will be the anvil. This is a steel plate that I had kicking round. This bar here is the other piece of bar you saw. The dies here will be made out of a part of a sledgehammer head. I managed to get a big I-beam off eBay for not a lot of money that I'll profile to make this. And I've decided to make it into an air power hammer or a pneumatic power hammer. So I've looked at Joshua Delisle's video and taken on board some of the bits and pieces that he used, and I've also looked at the Big Blue 110 power hammer and used very similar sized pneumatic equipment to that. So the anvil and the top and the pneumatic ram will be very similar to the Big Blue. So this is the cylinder that Joshua recommended on his power hammer build. It's a 63mm by 250mm stroke length double acting pneumatic ram, and then there's a 5-way valve. So I'm using very similar bits and pieces to what he recommended, and it seems to be a good match for the weight of hammer or top that I'm using. piece of steel that I'm going to use for the anvil weighs about 390 kilos. I think it's just too heavy to put on my machine. I'm not sure I could fit it on there safely anyway. So I'm having to do everything by hand. It's got a saw cut, well, it's got two saw cut ends. The ends seem to be reasonably true to the outside diameter, so that's good. So I've just cleaned these up with a file, and then I've created a central hole, which I did just by measuring off from the sides, and I've drilled and tapped that M10. I use this little guide that I made in the lathe to ensure that I was drilling straight, and that will be the marking point, or the holding down point, for my plate that I will drill and then use as a template to drill the rest of the holes. The bottom plate was drilled on the milling machine using the DRO, and I've just at the moment punched some 8.5mm holes through it, and I'm going to use those to transfer onto the main column, main anvil. I was using the DRO, just a few things to note. This DRO is really cheap, but it has got some foibles. The first one is you can see that the y-axis isn't on 0. It's a bit susceptible to EMC, so if you turn the switch on this milling machine, occasionally it jumps. I think I need to do something about that, maybe some better shielding. The other thing is the DRO function is a bit odd. If you put diameter in, it actually means radius, and if you want 8 holes you need to put 9 in, so it's slightly strange, but as I say, I think the whole DRO kit on this milling machine, which is a reasonable sized milling machine, was less than £200, so I can't really complain too much. This is the power hammer pretty much done, apart from some cleaning, painting and a bit of tidying up of the piping. So I'll just go through some of the features of it that maybe weren't apparent during the build video. So you can see if we start from the bottom, there's the base plate. I'll eventually be mounting that on a big oak platform. You've got the anvil arrangement. Clamped to that is the main backbone of the power hammer. And then we have the ram guide at the top. You can see the two ram guides bolted there with the ram and then the pneumatic ram tucked in behind. And then up there is the valve. The valve is actuated by a foot pedal down there. I didn't really cover much of the build of that because it's just basic fabrication. The foot pedal is sprung upwards by those springs, and then there's a rod that goes up the back that when you push the pedal down actuates the valve, and then from the valve there's an air supply to the top of the pneumatic ram and an air supply to the bottom. Mounted on the anvil and on the ram are those sledgehammer heads, the dies. And you can see you've got the trunnion there with the pin through it on the lower part of the ram, and there's a spring to decelerate the ram as it hits the top. I haven't quite finished it off, but there is where the bump stop will be mounted. When the glue's dried, it'll be fixed to there. And then you can see the screws that align the two ram guides, and these allow the ram to be lined up to the lower die. On the other side of the hammer we have a temporary rigged up air supply into the other side of the valve, and there are the two outlets. I think eventually I'll put some silencers on there, and then at the end of that pipe we have some three-way inputs. So I have 3 compressors, and depending on how much air we need I can use all 3 in tandem. And here is a view of the foot pedal arrangement mounted on the bottom of the power hammer. You can see there's some adjustment on there for adjusting the setting and the height of that foot pedal. So looking at the top of the hammer, you can see the support for the pneumatic ram, and you can see the pivot point there with the snap rings on it. I didn't really show much of the manufacture of that part. And here's an overall view of the hammer. This is with the plumbing done and the bump stop in place. So you can see the supply pipe there and the bump stop. And that 3-way arrangement mounted on the bottom there.